So before I get into this topic, I want to bring up all those little locker combination Pythagorean triples because I use those a lot on this so that you don't have to actually do the Pythagorean theorem and end up with a weird square root. Like occasionally I'll throw one in there that has a weird square root, but I like to use them a lot because isn't dealing with a whole number better than dealing with a square root? Like anyway, I try to cut you a break there. The first two I kind of want you to know. So does anyone remember one of them? One of those little triples. 3, 4, 5. Close.
Is it 7, 12?
5, 12, 13. Good. There's one that has a 7. 7. Oh, good. Nice job. There you go. And then you had almost the last one too. It was 8, 15, 17. You can do with those what you want. You can turn your back on them and be like, no, I'm not going to memorize them. I'm just telling you up front, your life will be easier if you do, because you won't have to do the work. You'll be able to just fill it in. Okay, so that you can do what you like with that information. Here are the sum and difference identities. Again, you don't have to memorize these. I'm going to give you a formula sheet that has them. What do the words sum and difference mean? Like, what does sum mean? Adding, difference means subtracting. Okay, so see how you're adding and subtracting in these? That's why they're called the sum and difference formula. So looking at this first one, pi over 2 is the A, 2 pi over 3 is the B. Here's the most common mistake. People will make it a negative 2 pi over 3. The negative just indicates that you're subtracting. It tells you which one of these formulas you're going to use. Do you see how this is sine and we're subtracting? It means you're going to use this formula right here. Do you see the sign of A minus B? It doesn't mean the angle's negative, it just means you're using that formula, okay? Now off to the side here, we have to draw a picture for both of those. That's like the work, okay? Pi over 2, where's that? Up, down, left, or right? Up, good. You still have to know the unit circle, guys. It's never going away. That coordinate point is 0, 1. That's like the work for that one. And then 2 pi over 3, what quadrant is that in? 2, good. Your reference angle is pi over 3. What goes across from that? Good, square root of 3 over 2. That means the other side is a half, but it is negative, good. Okay, that's like your work. Now you're just gonna use the formula. Yeah, it's kind of boring, but you just read the formula and plug everything in. This is the one that we're using. It's sine and subtraction. So look, here's the first part. Sine of A. This one was A. If you want to even label them, like this is A and this is B. Okay. Sine of A. Sine is the Y value. So what's that going to be? 1. Good. That first part is 1. The next part says cosine of B. So here's B. Which part of this is cosine? Good. The negative a half. And I'm still just reading off the formula, like literally just follow along. I'm pointing to it. Minus cosine of A. So this one's A. Cosine is what part of that? 0. And then it kind of doesn't matter what this last part is because 0 times anything is going to be 0. But just to be thorough, we'll finish it up. Sine of B. That would be square root of 3 over 2. So again, 0 times anything is 0. This part is going to be gone. And so what's your like final answer to the whole thing? Yeah, 1 times negative a half would just be negative a half. And so that's your answer. So you draw a picture for each of the angles, and then you use the formula. Now this one, we're going to have to figure out what we're adding ourselves. You want to pick angles that are on the unit circle, okay? Because those are the ones we can evaluate. So we're going to need to rewrite this as cosine of something plus something else. And I'm obviously going to tell you because I'm your teacher, but I'm going to throw the question out there first. We want to add 2 things together to equal 7/12. And so they're both going to be 12s. Any thoughts on what you might want? Like numbers that add up to be 7, we're going to need them to work. 3 and 4, right? Because if you pick 5/12, there's 5/12 on the unit circle. Like you could do 5 plus 2, but 5/12 isn't going to get you anywhere. If we do 3/12 plus 4/12, now those fractions will reduce to what? If we just reduce the fraction. Yeah, pi over 4 plus pi over 3. Good. And both of those are on the unit circle, so we're good. So now it's just like number 1. Cosine, and we're adding. So this is the formula that we're going to use. Do you see the one I'm pointing to? Cosine, and there's adding. So this is the one we're going to use. This is A, this is B, if you want to label them. And we're going to draw a picture for each of them. So here's pi over 4. What are both the sides going to be for that? Oh, wait, question, go ahead. Yeah. It technically doesn't if you're the other way around. So if you did the pi over 3 first and then the pi over 4, yours is going to look like a little different for me, but we'll get the same answer at the end. Yes, it does not matter. Now, it doesn't matter what order you add, but it does matter what order you subtract. Subtracting makes a difference. All right, so what are the sides for both of these? Yeah, good. Square root of 2 over 2. And then I'm going to draw the pi over 3. Across from that, you have root 3 over 2. And then the other side is a half. So these pictures, again, that's like your work. And then you just have to pick which formula you're using and plug it in. And again, if you want to label, this is A and this is B. You don't have to do that. I'm just saying if you want to label them, you can. So this is the one we're using. I'm just going to point to it. Just follow along with me. Cosine of A. This one's A. Cosine would be what? You can't mess it up, right? Because they're the same thing. Okay. Square root of 2 over 2. And then still following along with the formula. The next one says cosine of B. Now this one's B. Cosine would be which one? 1/2. And then we've got minus, again, just still reading along here, minus sine of A. This one's A. Sine would be square root of 2 over 2. And then sine of B is square root of 3 over 2. Now, unfortunately, none of them came out to be 0. The first one was sort of nice. We ended up with a 0, so that was kind of just gone. So we're going to have to actually like figure this out. If you multiply these first two together, your numerator is just going to be square root of 2. Anything times 1 is not going to change. Denominator would be what? 4. Good. 2 times 2 is 4. Don't overthink that. Minus, now if we multiply these together, square root of 2 times square root of 3 would be square root of 6. 2 times 3 is 6. Again, please don't overthink that. And the denominator, conveniently, is going to be 4. So they have a common denominator. You're just going to put it together. It's going to be square root of 2 minus square root of 6 all over 4. That's your final answer. And I hope you're at the point where getting wacky answers doesn't bother you anymore, because we're so far beyond that at this point. Like, are you used to the answers being nonsense? I actually get to the point where a lot of people are like, when they get a nice, neat answer, they're like, I did something wrong. And I'm like, no, just accept whatever you get. All right, these ones are not on the unit circle. We're going to use these little locker combinations. All right, let's draw them off to the side. Let's draw A. This one will be A. Tangent of A is 5/12. Tangent is what over what? Because we're back to SOHCAHTOA. Good. Opposite is 5. Adjacent is 12. If you have been paying attention, what is the hypotenuse with no work? Good. And then I'm going to draw another triangle for B. This one's cosecant. All right, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So this would be hypotenuse over opposite. We just flipped it over. So what does that mean this side is? 3. Cool. All right, now we're just going to use, this is like our work, okay? Now we're going to pick which formula we're going to use and just plug it all in. So it's cosine and we're subtracting. So that's this one right here. Are you guys seeing that there? And it's like a lot on the paper. All right, cosine of A. Here's A. Cosine is adjacent over hypotenuse. So that'll be 12/13. And then the next part of the formula says cosine of B. All right, what is cosine of B going to give us? Three over 5. Good. And then we have a plus sign. Again, just reading along with the formula, plus sine of A. So what is sine of A? 5/13, good. And then lastly, sine of b, 4/5. And then we're just going to multiply the fractions together now. They're going to have a common denominator again, so it's going to be fine. All right, multiplying these together, 12 times 3, 36, 13 times 5. If you don't know that off the top of your head, you can work it out off to the side. 5 times 3 is 15. 5 plus 1 is 6, so 65. Some people have like a calculator in their head and can do that. I usually just write it down. Go ahead. Are you sure?
I was gonna ask how to do
Okay. Okay. If you change your mind, just let me know. All right. And then 5 times 4 will be 20. And then 13 times 5 is 65. And then you just add those together and reduce it if you can. If not, then it's just your answer. So what will that give us? Yeah, good. 56/65. That, I don't think that reduces. So we're just done. That's it. So again, to summarize, you pick which formula you're going to use. You draw these. That's like your work. And then you just plug them in. You don't have to memorize them. Are we okay? Or a question before we do the next one? Go ahead. No, like a half point. I mean, like, and I think if it reduces, you're probably going to know. Yeah, that's really weird. It looks like it might, but then it doesn't. I mean, okay. We'll do the double angle ones, and then I'll give you a break before we do the half angle ones. These are all your double angle identities. Again, you don't have to memorize them. I'm going to give them to you right here. There's 3 different ones for cosine of 2a, like doubling the angle. I just always use the first one for no other reason than it's the first one and you have to pick one. I mean, it doesn't matter. You're going to end up with the same answer anyway. But sine, cosine, tangent of doubling the angle. Now, it's nice when you have parts A, B, and C because you only have to draw the pictures once and then you use them for all 3 parts. So I was trying to like have you catch a break there. Given that sine of A is 3/5 and the angle is in quadrant 2. All right, so off to the side here, we're going to draw a triangle in quadrant 2. It's angle A. Sine is 3/5. So sine is what over what? Good. So 3 is the opposite, 5 is the hypotenuse. What's the other side? And be a little careful with this one. Good. Why is it -4? Yeah, we're in quadrant 2. So it's 3, 4, 5, but you just have to watch your negatives, right? We're going to use that picture for all of these. Okay, so that's the only picture you have to draw. So sine of 2a, here's the formula right here. It is 2 times sine of a, which is 3/5, times cosine of a, which is adjacent over hypotenuse, -4/5. And then you just multiply that stuff together. 2 times 3 would be 6, times 4 would be 24, except it's negative. So -24 over 5 times 5 is 25. That's it. Good, and you can write it as 2/1 if you want. That helps sometimes. You're doing 1 times 5 times 5 for the denominator. Yeah. All right, cosine 2a. Again, you can use whichever one of these you want. I just always use the first one. We're going to do cosine squared. So cosine is -4/5, and we just need to square that. It just has a squared in the formula. Minus sine squared, and sine is opposite over hypotenuse, that's 3/5. So again, you just pick which formula you're using, plug in. Now, when you square something, it's always positive. Negatives cancel out. So what will this first one give us if we square the 4 and square the 5? Good, 16/25 minus, and then this one would be 9/25, good. And then subtract 16 minus 9 would be 7, so 7/25. And then last one, tangent. Here's your formula for tangent of a double angle. 2 times tangent of A. All right, look at your picture. What is tangent going to be? Good, 3 over -4. And then that's over, so you have a fraction bar here, 1 minus tangent squared. And we just said tangent was -3/4. All right, so in the numerator, again, you can put the 2/1 if that helps you. This would be -6/4. And then down here, we'll have 1 minus, all right, what do you get if you square this? 9/16. So it's 1 minus, but then this turned positive because when you square something, it's positive. All right, how would this reduce? This -6/4? Good, -3/2. Down here, here's what I would do. I would erase the 1. If you're writing with pen, scratch it out. I need for it to be 16ths. So I would rewrite 1 as how many 16ths? Yeah, 16 16ths, and then you can subtract that. 16 minus 9 is 7, so 7/16. So that looks like fun. You have a fraction over another fraction, but do you remember how we deal with that? Good, multiply by the reciprocal. You're just gonna flip it over. So let's see, -3 times 16, that'll be -48. 7 times 2 is 14. That does reduce. I can tell that reduces because they're both even numbers. It'll divide by 2. So that'll be -24/7. All right, so these ones are the half angle identities. See how they're all A/2, so it's half of what you had. Again, you don't have to memorize those. The reason for the plus minus is that it depends on what quadrant you're in. I'm gonna keep all these in quadrant 1, so they will all be what? Positive, okay, so that you don't have to worry about that. But that's what the plus minus is there for, is if you were in a different quadrant, you'd have to worry about whether it was positive or negative. So sine of pi/12. I hope that you know pi/12 is not on the unit circle. So if you go to evaluate that, you would be like, well, how do I do that? Pi/12 isn't on the unit circle. So we're going to rewrite it as something over 2. And I want that something to actually be on the unit circle. So what can I put there over 2 that'll give us pi/12? Six, because if you have pi/6 and then divide by 2, if you divide by 6 and then divide by 2, 6 times 2 is 12. Oh, no, it has to be on the unit circle. Are you with me now? Okay, so pi/6 and then divided by 2 would give you pi/12. So pi/6 is your like A value. And so that's what we're going to draw a picture of off to the side, is pi/6. And so what goes across from the pi/6? 1/2. That means this side is square root of 3/2. So that's your work. And then you just use the formula and plug in. These ones are going to look particularly nasty because of the big old square root that's in there. You'll be okay, right? So sine is this one right here. It's positive. I'm going to make them all positive. We're going to stay in quadrant 1. So draw yourself a gigantic square root. It is 1 minus, and then cosine of A. So look over here. What is cosine for our triangle? The x value, so square root of 3/2. And then that is all over 2. Now, when you go to simplify this down, it is like quite a mess. Do you remember how on the other side we changed the 1 to 16/16? Here I'm going to change it to 2/2 so we can have a common denominator with these. And then I can put them together. So it will be 2 minus square root of 3 all over 2. I just put those together. And then that's all over 2. Having fun yet? So here's the question. If you divide by 2 and then you divide by 2 again, you've really divided by 4, okay? So what we have here is 2 minus square root of 3/4. All of that is underneath of a square root. Now, I really can't do anything with this because that's just a mess. But what is your square root of 4? Because you can do that one. 2. Your square root of 4 is 2. So this final answer is square root of 2 minus square root of 3. And then that's all over 2 because your square root of 4 is 2. Yes, there is a square root underneath another square root. It's just in the formula that there's a division by 2. So we had 1 minus, and I changed the 1 to 2 over 2. We had 1 minus square root of 3 over 2 was the cosine over here. And then that's all over 2. So there was just another division by 2 like in the formula. We're going to do it again. You'll see it. We're going to practice it again. I made this one have parts. The reason I did that is so you can only draw one picture. Okay. Given that A is 5/13 and is in quadrant 1. So draw yourself a triangle in quadrant 1. Sine is opposite over hypotenuse. And what's the other side going to be? 12. You can label that A if you want to. We're going to use that picture for parts A, B, and C. All right, so this says sine of A over 2. So we're using this first formula. It's positive because we're in quadrant 1. Great big square root. 1 minus cosine of A. Cosine over here would be what? 12 over 13, adjacent over hypotenuse. And then that's all over 2. Again, that over 2 is just part of the formula. So I kind of can't get rid of that. Now, what should we replace the 1 with? I'm going to erase the 1. What are we going to replace that with? Good. 13 over 13. And then you can subtract those. 13/13 minus 12/13 is 1/13. And then that's over 2. So if you divide by 13 and then you divide by 2, it would be 1 over what? 26. Good. 13 times 2 is 26. There is not anything I can do to make that any better. So I'm just leaving it. 26 is not a perfect square. That's just a disaster. Okay. I don't need to draw a new picture. We're going to use the same one. Only difference is this one says cosine. So we're going to use this formula. Again, it's positive because we're in the first quadrant. So great big square root. Now you'll notice these are actually the exact same formula, except what's the only difference? It's a plus sign. So it's going to be exactly what you just did, except plus. And so again, I'm going to erase the 1 and rewrite it as 13 over 13. And we're just going to add them together. So what will that give us? Good. 13 plus 12 will give you 25. So 25 over 13 over 2. And so that'll be 25 over 26. Again, 13 times 2 is 26. You divide by 13 and then divide by 2, you've divided by 26. Now that one we can actually go a little bit further on, because what is your square root of 25? Is 5. So you have 5 over square root of 26. And that'll be 5 square root of 26 over 26. I didn't bother with this one because there was just nothing I could do to that. So I just left it alone. There are ways you could simplify that further, but I was just like, yeah, whatever. All right, and then last one, tangent. Same picture, because this is parts A, B, and C here. We're just going to use the tangent formula, which is right here. It's positive because we're in quadrant 1, so draw yourself a big old square root. It's going to be 1 minus cosine over 1 plus cosine. So 1 minus cosine, again, is 12/13 over 1 plus 12/13. And again, I'm going to erase the 1s and write them as 13/13. This is the one that looks the worst, but it actually turns out not bad because we're going to get some stuff to cancel out here. So what do we have for the top part? Like, what is this going to give us? 1/13. And then down here, 25/13. And I realize that looks awful, but what's going to happen then? Yeah, those cancel. It's just 1/25. And your square root of 1 is 1. Square root of 25, 5. So 1 over 5 is your final answer. So again, you just pick what formula. You don't have to memorize them. I'm going to give them to you. You draw a triangle. That's your quote unquote work. And then plug it all in.